Hey there, folks. In this video, we are going to be adding and subtracting rationals. So we're going to add and subtract rational expressions. Now, a rational expression basically is any time we have something with a numerator and a denominator in which there's an x in a denominator. So anytime you see an x in a denominator, or a variable of any sort, I guess I should say, that's a rational function. Now, when we're adding and subtracting, these are going to behave just like fractions. So let's get some fraction practice. I'm going to make up some simple guys. Let's go 1/2 plus 2/3. If I want to add these fractions together, a big common mistake people make is they'll do 1 plus 2 equals 3 over, that'd be 5. And that's incorrect. If we want these fractions to be addable, I guess if that's a word, if we want to be able to add them together, we need to have common denominators. So if we don't have common denominators, there's really nothing we can do. Let me change the angle here. So we need to figure out what is a denominator that I could change both 2 and 3 into. Well, I know 2 and 3 both go into 6. So if I put this out of 6, then I can go ahead and add the numerators together. All right, well, how do I change a 2 into a 6? I can change the value of a fraction by simply multiplying both denominator and numerator by the same value. If I multiply top and bottom by the same thing, I'm not changing the value of the fraction. I'm just changing the appearance of it. And I'm only allowed to do this by multiplying or dividing by a constant value. So down below, 2 times 3 or 3 times 2 is 6. We knew that. Up top, 3 times 1, that would be a 3. Similarly, over here, I want to turn a 3 into a 6. Well, to do that, I need to multiply by 2. And whatever I do to the bottom, I have to do to the top as well. So I'm not changing the value of this fraction, just changing the appearance. That would be 4 over 6. Essentially, I kind of unsimplified. I've unreduced, right? 3 over 6, we would typically reduce that and call it 1/2. They have the same value, but we're writing it in this form for the advantage of them having the same denominator. Well, now I can go ahead and add. If I have 3/6 over here and 4 more sixths over here, that means I would have a total of 7/6 altogether. So the big concept here is we have to get a common denominator. Well, that's going to translate to these types of problems. Now, when we do these, first thing you want to do is make sure everything is as factored as possible, especially when looking at the denominators. If I ever see a GCF, I want to factor that out. So over here, I'm seeing a GCF. And if I ever see a variable squared, that's typically an indication that some factoring can happen. So yeah, I'm anticipating some factoring having to happen over here. This first one, let's call this number 1. This is already factored for me. Unfortunately, though, my denominators are not the same. Well, quick fix. If I wanted these to match, this has a 2 and an r plus 5. This already has a 2, so if I just tacked on an r plus 5 over here, well, now they're the same. All right, well, if I multiply an r plus 5 down there, I have to do the same thing over here. I have to be consistent. So now what I'll have is a 3r plus 3 over the 2r plus 5. And then if I distribute that in, 5 times r is 5r, 5 times 5 is 25, all over my denominator, 2 times the quantity r plus 5. Well, now let's just combine like terms. I've got 3r plus 5r, that is 8r. 3 plus 25 is 28, all over 2 times the quantity r plus 5. Well, that's pretty cool. So that would be a final answer. Unfortunately, it's not entirely reduced. And what I mean by that is at the very, very end, there's a chance I could maybe reduce this down further. So I'm going to do this next part in purple so we know it's going to separate. I'm noticing up top here, I've got a GCF of, let's see, 4, right? So 4 can be pulled out of 8. We'll call it 2r. And it can be pulled out of 28, and that would be a 7. The reason I was doing that is, well, now I'm seeing, hey, 4 can reduce down with that 2. So I could divide this 2 away essentially by cutting each one of these in half is what's happening. So I could write this as 4r plus 14 all over this 2 got canceled out. So I'll write it as a 1, but you don't have to write it. So that would be the reduced version. Not reduced, reduced. Okay. Next one, we will call this one number 2. Here, there's really nothing to factor, but I am noticing, hey, there's a minus sign. Anytime I see a minus sign, what I'm going to typically do is change that to a plus, and then the numerator of the fraction that follows, make that a negative. And that's just going to be a nice reminder for me if I have to do some distribution. It still says the exact same thing, only now it's adding a negative number. All right, these denominators are not the same. Shucks. I want them to be the same. So I need to multiply something to this denominator and multiply something to this denominator, something totally different, so that they look identical. Well, if you're ever in a bind, and this might not be the least common denominator, in this case it will be, but it won't always, just multiply your two denominators together. I'm just going to multiply p plus 3 and p minus 2 together. This first fraction, or rational expression, already has the p plus 3, but I need to multiply that by a p minus 2. Whatever I do to the top, or sorry, to the bottom, I have to also do to the top. The second ratio already has the p minus 2 taken care of, but it's missing the p plus 3. So I'll multiply that to the top as well. I should make note, these two denominators, now that I've kind of altered them, they are the exact same thing, even though they're written in a different order. It's just like saying 5 times 10 is the same as 10 times 5. It doesn't matter the order in which you multiplied two pieces. All right, so now let's clean things up. 4 times p is 4p, minus 4 times 2 is 8, so 4p minus 8. Over here, a negative 3p and a negative 3 times 3, negative 9. So negative 3p minus 9. All right, let's combine like terms. We've got a 4p and negative 3p, that is a 1p. You don't have to write the 1 if you don't want to. Negative 8, negative 9 is a negative 17, all over my denominator, which is p plus 3 times p minus 2. Or if you had those things flip-flopped, it's the same thing. If you have p minus 2 times p plus 3. And we're done. All right, on to slightly more challenging ones. Let's call this guy number 3. I have 5 over 2 times v. I'm going to put a little multiplication dot in there so we know that those are actually two separate pieces being multiplied together. And then over here, let's see. Ooh, I've got a minus sign, so I'm going to change that to plus a negative, and that negative is actually going to affect that whole numerator. Okay. I want to factor this thing out. So instead of 2v squared minus 2v, if I take out a GCF, that would be a 2v. If I divided a 2 out of this, that's a 1, take away one of the v, so v minus 1. So that's what this thing looks like in factored form. Now the reason I'm doing that is I want to be able to kind of figure out what is missing. If this is my least common denominator, I'll call that LCD, least common denominator. I want both of these denominators to look just like that. Well, this one already does, right? Because we just factored this to get here. This one's already got the 2, check. It's got the v, check. Ooh, it's missing that v minus 1. So if I just tack on a v minus 1 down there, well, now these are saying the exact same thing, right? Whatever I do to the bottom, I have to do to the top as well. All right, so let's make this pretty. 5 times v and 5 times negative 1. That's 5v minus 5 over, we had 2v, v minus 1. And over here, if this negative sign affects both pieces, that would be negative v minus 6 over, and I'm going to use the factored form here, 2v, v minus 1. I could write it as 2v squared minus 2v. These two things are saying the exact same thing. Okay. Well, let's combine our like terms. And when all is said and done, things might cancel. Who knows? 5v and a negative v, that would give me 4v. Negative 5 and a negative 6 is a negative 11 over 2v v minus 1. And if you chose to write this denominator in that form, that's totally fine. Now, some of you might be thinking, hey, why are you boxing this right now? We reduced number 1 because we saw the 2 out here, and the 2 reduced with the 8. Why the H aren't we doing that over here? Hello, 2 and 4, V and V, what's going on, man? Well, the reason is this 2, yeah, it can reduce with the 4. However, it can't reduce with the 11. You need to be able to divide this 2 out of everything up top. The reason we could do it over here is that 2 divided out from the 8R and from the 28. This 2 cannot divide out from the 11. This V, while yes, it could cancel out with this individual term, it cannot cancel out with this individual term over here. When we are canceling or reducing, you have to cancel an entire factor, not an individual term. All right, last and final one, folks. Oh, you know what? I already see something that's going to make my life a bit easier. By the way, let's call this number 4. 4x over 5x. I'm just going to simplify right now. You know what? Like x over x, those cancel each other out. All right, let's make our lives easier if we can. All right, we need to factor this guy. So this denominator, let's see, 50x minus 40 GCF of 10. I'm left with 5x minus 4. Well, holy smokes. Check this out. We've got the 10s are going to cancel now. All right, so before I even tried getting a common denominator, a whole bunch of cancellations happened. We're at 4/5 plus, I canceled away the numerator, so I'll just use 1 as a placeholder, and 5x minus 4. All right, so now let's get our common denominator. Now, some of you may think, all right, this already has a 5. We just need an x minus 4. It doesn't quite work that way because this 5 is attached to the x, but that's a separate term than this minus 4. So we actually need to multiply this first fraction by 5x minus 4. Whatever I do to the bottom, got to do to the top. And I actually need to multiply this rational over here by a 5. So now both denominators have 5 times the quantity 5x minus 4. All right, just like we did before, let's distribute. 4 times 5x, 20x, minus 4 times 4, 16. All over our common denominator, 5 times 5x minus 4. Over here, 1 times 5, brain buster, 5. All over our common denominator, 5 times 5x minus 4. Ugh. Now, some of you might be saying, hey, can't we reduce this? Well, yeah, we could, and we'd wind right back up here, but we don't really want to do that because as soon as I cancel that out right now, these no longer have the same denominator, and I need that in order to add here. So let's do our addition. 20x, and there's no x's over here, so 20x it stays. A negative 16 plus 5 is a negative 11 over 5 times 5x minus 4. There's no GCF up here, and 5 can divide out of 20x, sure, but it doesn't divide out of the 11. So I can't really reduce this any further. This would be our final answer. All right, folks, you know the drill. If there was anything that confused you, please, please, please let me know. As always, good luck, have fun, be safe, roll tide.